We are now going to the exam questions regarding this lesson. The first of which is this one. Using the substitution u equals 3 to the power of x, or otherwise, solve correct to three significant figures the equation 3 to the power of x equals 2 plus 3 to the power of minus x. Now, how are we going to tackle this question? You have these two terms that are very similar. This is 3 to the power of x, this is 3 to the power of minus x. The base is the same, you just have a minus there. Well, you can use one of the rules regarding exponentials to send this x to the power of, to send this minus, to the power of the x. And that's exactly what we're going to do. Not this one, it's this one over here. So, first thing, we are going to put this minus as a power of 3 to the power of x. And now, since we have these two terms that have the same base, we can make a substitution. We'll call it just u, and therefore this will become just this. U equals 2 plus u to the power minus 1. So, how are we going now to solve this? We can transform this, if you pay attention. You've done this already last year. You can turn this into a quadratic. All you have to do is to multiply everything by u. So u times u is going to be u squared, 2 times u is 2u, and u to the power minus 1 times u is 1. And now this is a quadratic you can very easily solve. I used the quadratic formula and I ended up with these two values. First, u equals 1 minus square root of 2, and then u equals 1 plus square root of 2. We have to undo this change of variable at the end. So actually what we do have is 3 to the power of x equals 1 minus square root of 2, and 3 to the power of x equals 1 plus square root of 2. You have to be aware that square root of 2 is more or less 1.44. So 1 minus that, this is going to be a negative value. And since this is a positive base to the power of x can never be a negative value. So this is impossible. This one isn't. So this is the one you have to work with. So in order for you to get the value of x, all you have to do is to do the inverse of this, which is the logarithm base 3 of this. You apply this to both sides. This will become just x. And this will become this result over here. Now you have a division of two logarithms, and you can apply the rules. This is going to be what you have inside of that minus 3. Just put that on a calculator, and you will have this value over here, correct to three significant figures as you were asked. One more question. This is, by the way, this was the question, where is it? Question 4 from a paper 3 from June 2007. This is a question from spring 2014, a question paper 33, and the question itself is question 1. It says, solve the equation logarithm base 10 of x plus 9 equals 2 plus logarithm base 10 of x. How are you going to tackle this to begin with? You have here two logarithms with the same base. They are in opposite sides of an equation, so if you put the whole thing into one side, you can apply the laws regarding logarithms to turn this into a single logarithm. Then you can turn the two sides of the equation and place them as a power of the same base, in this case 10, and therefore get rid of the logarithms and solve the equation. Let's look at it. So this is what you start with. I've just sent the logarithm of x to this side of the equation. You have the difference of two logarithms, so you can do this. And now you have a single logarithm on one side and a 2 over there. So what you have to do now, you have to apply to put everything as an exponential of base 10. So you have 10 logarithm base 10, you cannot see it, but this is base 10 of x plus 9 over x equals 10 squared. Now these two cancel out. You are just left with the fraction, and 2 squared is 100. And now all you have to do is to solve this very simple equation. By solving it, you'll get the value x equals 1/11.